Now children, we solve some numerical problem based on this diffraction chapter. Okay, the problem number 1, let's start with problem number 1, and problem number 1 says that front of a diffraction from a single slit of width 1.24 into 10 minus 6 meter. So 1.24 into minus 6 meter is the width of the slit, the width of what? Single slit, and this width of the slit is given by E, 1.24 into 10 power minus 6 meters. So this is the width of the single slit. So let me do the solution of this question. Is observed with light of wavelength. So what is the wavelength of light? So wavelength of light is lambda, which is 6200 Armstrong. So this wavelength, which is in Armstrong, we need to convert into what? Meter. So what I do, I multiply by 10 to minus 10 meter. So 10 to minus 10 meter. But children, this can be further simplified and written as 62 into minus 8 meter. We can write this way also. So your wavelength is 62 into 10 minus 8 meter also. Okay. The question says that calculate the angular width of center maximum. You have to calculate the angular width of what? Center maximum. And this is one of the question came in ISC 2005. Okay. The angular width of center maximum can be measured either in degree or in radian. So what I do, I calculate first in degree, and I'll show you to calculate this in radian also. And for center maximum, let me write down for center maximum. The center maximum is also called principal maximum, and your angular width, there is a formula of angular what? Width. And the angular width of center maximum, principal maximum is actually 2 theta 1. 2 theta 1. So to measure this angular width in degree, it will be 2 sine inverse lambda by E. 2 sine inverse what? Lambda by E. So when there is sine inverse of the quantity, we measure this angular width in what? Degree. So it will be 2 sine inverse lambda means how much? 62 into 10 to the minus 8 by E, that value is given 1.24. 1.24 into 10 minus what? 6. Yes, we can remove the decimal and cancel. Okay, so it will be 2 sine inverse 62 into 10 power 2. I write down because after decimal 2 numbers, so I wrote 2, and there is 10 to the power minus 8 by 124 into 10 to the minus what? 6. So 62 1 is 63, 62 2 is 124. Now again we can further simplify. 2 sine inverse 10 to the power 2 minus 10 to the minus 8 means 10 to the minus 6 by 2 into 10 to the minus 6 also. So 10 to the minus 6, 10 to the minus 6 cancel out. There is 1 in the numerator, which means 2 sine inverse 1 by 2. And children, you know 1 by 2 value of sine is sine 30 degree. So I write down 2 sine inverse. So value of 1 by 2 means sine 30 degree. And you know in trigonometry inverse theorem, sine inverse sine theta, like sine inverse sine theta means theta. So in the same way, sine inverse sine 30 degree means 30 degree. So it means 2 into 30 degree means 60 degree. So we can measure the angular width of center maximum in degree, and is coming 60 degree. So in your examination, if it asks angular width not to calculate in any of the angle, now you can calculate any of the angle. Means we can calculate in degree, or we can measure in the radian also. So we can measure the same angular width in radian also. So in radian also we can measure this way also. Angular width is simply given by 2 theta 1, and the formula is simply 2 lambda by E. Just we need to use this formula, 2 lambda by E. Okay, so 2 into lambda means, see, again same thing. The value of lambda is how much? Yes, it is 62 into 10 minus 8, and E means what? 1.64 into 10 minus what? 6. Now see, this lambda by 2 E value which we have calculated is 1 by 2. So I write directly 1 by 2 also. This is 2 into 1 by 2. I can write this way also. 2 into 1 by 2, and this means 2 to cancel out is 1, and it will be radian. So when you write 1, and the unit will be radian. So either the answer will be 60 degree or 1 radian. So this is how we can calculate the angular width of center maximum. And this is the explanation of problem number 1. Now let's do next problem, that is problem number what? 2. Now problem number 2 says that a parallel beam of light of wavelength 600 nanometer. So solving this problem also. Let me just write it down. The wavelength of light which is given, lambda, that is 600 nanometer. So this wavelength which is given in nanometer. So again I convert this nanometer into meter. So I don't know 600 into 10 to minus 9 meters. So children, this relation you need to understand or need to know, that is new nanometer with me convert to meter multiply by 10 minus 9, because nano means the order 10 minus 9. So this value can be written now as 6 into 10 minus 7 meter also. So this is the wavelength of light. For normally on a narrow slit of width, so slit width means E, that is 0.3, it is given 0.3 millimeter. There is a narrow slit of width 0.3 millimeter. So 0.3 millimeter, but I convert this millimeter into meter. So multiply by 10 minus what? 3. So this is the width of the slit. Now in this question also what we need to calculate? Calculate the angular separation. Angular separation between the first minimum and the center maximum. So the first part of the question where we need to calculate the angular separation of first minimum and center maximum means you have to calculate half angular width of center maximum. Angular width of separation between first minimum and center maximum means you have to find half angular width of center maximum. Just showing with the help of diagram. You know this is center maximum. Then after we come to first minimum. This is first secondary minimum. This angle actually we need to calculate. And you know this angle is given by theta 1. The angle of separation between first minimum and the center maximum is theta 1 that we need to calculate. Means theta 1 means outer nothing but the half angular width. We also call this as half angular width. And we can calculate this in radian also. And the formula is, since theta 1 is simply lambda by E. And when we calculate this theta 1 in radian. So remember when theta 1, the angular width separation between first minimum and center maximum, when we calculate in radian we use this formula, that is theta 1 equals to lambda by E. Alright. So let's substitute the value. Lambda means how much? 6 into 10 minus 7 by E means how much? 0.3 into 10 power minus 3. Okay, so let me remove the decimal and write 6 into 10 into 10 power minus 7 plus 3 by 3. So I remove decimal, 10 I wrote, 10 minus 3, if I take in the numerator, plus 3. So 3 1 is 3, 3 2 is 6. Means 2 into 10 power is 1. Now minus 7 plus 3 means minus 4. Minus 4 plus 1 means minus 3. So it is coming 2 into 10 to minus 3 and the unit is radian. What is the unit? Radian. So we calculated the angular separation between first minimum and center maximum, which is also called half angular width of center maximum. And the answer is 2 into 10 minus 3 radian. So this is the first part of the answer of this question. Now we calculate next part, that is the second part of the question also. In second part also we calculate the angular separation between first subsidiary means secondary maxima of two sides of center maximum. First subsidiary maxima means secondary maxima on two sides of what? Center maximum. Now to calculate this separation, let me again show you with our diagram. Just following this intensity graph. You know this is the graph. This is center maximum, this is first secondary maximum. This is also first secondary maximum. This angle, if I say, is theta 1, okay, for secondary maximum. This angle is also theta 1 for secondary maximum. See, I am dealing with the maximum. Now this whole angle we need to calculate. This separation that we need to calculate. Okay, so to calculate the angular separation for first subsidiary maxima, I use the condition of secondary maxima. I use the condition of secondary maxima. And you know the condition is, since for mth secondary maxima, secondary what? Maximum, okay, maximum, the condition is E sin theta m is equals to plus minus, okay, 2m plus 1 lambda by 2. So we have done it this part.